All right, we're on page 375. This is the first lesson of Module 3, Topic 1. So we're going away from systems and now we're talking about patterns, sequences, and rules. We're going to actually start with the warm-up here. We're going to do this real fast. So it says list 5 consecutive numbers. So like 5 consecutive numbers. You don't have to start at 1, but we could go 3, 4, 5, 6, 7. That's what it means to be consecutive. List 5 consecutive multiples of 4. So you really just skip counting by 4. 4, 8, 12, 16, 20. 3, list 5 consecutive multiples of 5 that decrease. So just think of any multiple of 5. So let's say like 35. All right, well, it's got to decrease though. So the next multiple of 5 that decreases is 30. Then you go 25, 20, and 15. And lists multiple consecutive prime numbers. So those are numbers that were they're only what do we call our factors are 1 in itself. So 2 is a prime number because the only numbers that multiply that equal 2 are 1 and 2. 3, only numbers that multiply are 1 and 3. And the same for 5, 7, and 11. So each number that we did not list, like 4, 6, 8, 9, 10, right? Those are all what we call our composite. They do have other factors than just 1 in itself. Okay. Anyways, so getting from that, so some vocabulary terms to more vocabulary terms here. On getting started, that is a sequence in terms. So a sequence is a pattern involving an ordered arrangement of numbers, geometric figures, letters, and other objects. And we'll be talking about patterns where like the patterns either like multiply, add, divide, subtract. And then a term. A term is in a sequence is an individual number, figure, or letter in that sequence. So we can say that this is a sequence, 2, 4, 6, 8, 10, 12. But each individual thing is what we call is a term. So like 6 is a term, 12 is a term, and so on. So we have a sequence here where it looks like we're adding by 2. We have another sequence of shapes. We've got a triangle, square, a rectangle, pentagon, and hexagon. So this, right, the sequence is that we're adding another side, right? We have, in this case, all right, 3 sides, 4 sides, 5 sides, 6 sides. And then for sequence C, think about what's happening there. 3, 9, 27, 81. All right, for each one, it's getting bigger. What's happening is you're multiplying by 3 to get the next term. Okay, number 1 we're actually not going to do, but I just want you to see an example of a sequence because we'll be doing that for activity 1, and that's the only activity we'll be working on for this lesson. Okay, so let's move on to page 377. Okay. All right, so for this, it says, in this activity, you will write sequences for various situations and analyze the patterns in those sequences. So for this one, it says taking apart a card trick. All right. It says Matthew performs a card trick. It is important that he collects the cards shown in a particular order. Each turn, he collects all the cards in the rightmost column and all the cards in the bottom row. So, let's highlight that. So for rightmost column and bottom row, just like this. All right. So number 1 is we're going to write a sequence to show the number of cards removed from during each of the first 5 turns. So let's just count. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So the first, when Matthew collects the cards, he's collecting 13 cards. But we're going to do this for the next 5 turns. So after he has that, he has this remaining rectangle. So now he's going to collect this. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then maybe from there you can kind of tell what the sequence is going to be, but we'll just continue it. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9. And I think at this step, we're not going to count the remaining ones, but I think we can tell. The next one should be 7, and the last one should be 5. So this is You can think about this pattern. Well, actually, we'll write it in. Number 2, write a sequence to show the number of cards remaining after each of the first 5. So after we took away 13, right, what remained? So what we're really doing here, let me erase this. So what remained here? All right, so this is, we don't have to count each one, but we'll count each row and column. So this is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. So multiply 5 times 7, that is 35. And then next, we're going to go here. How many cards remained there? That is 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So 4 times 6, 24. Okay. And the next one, how many cards are in this next rectangle? This is a 3 by 5, so that's 15. The next one is a 2 by 4, so that's 8. And then the last one is right here, that is 3. Okay, so what is the pattern in each of these sequences? So we have 2 sequences that are listed. In the first sequence, the number of cards decreased. I'll put 1 for first. It decreased by 2 each time. And then in the second, or you could just think it's like consecutive odd numbers. In the second sequence, the number of cards decreased by the values shown in the first sequence. So what I mean by this is from here to here, we subtracted 11. Here to here, we subtracted 9. Here to here, we subtracted, was that 7? And here to here, we subtracted 5. So it decreased by the, I'll say 1, so the first sequence values. Okay. All right, good. Anyway, so this is a good introduction into sequence, but we're going to keep exploring this idea into the next couple of pages. So let's move on to page 378. All right, arranging pennies. So here you can kind of see that we have like this triangular / pyramid shape of pennies. So let's read the situation. So Lenny makes arrangements with pennies. He has made 3 arrangements. And now he wants to make 5 more arrangements. So 5 more. Each time he adds another arrangement, he needs to add 1 more row to the base. The base is the bottom. And the row needs to have 1 more penny than the last row in the previous arrangement. So an example here, you can see how we have this 1. Well, we put 2 to add an additional row, and that became this, which is 3. Right, we added another row to make this arrangement, so that was 3 plus this other 3, right? This equals 6. Okay, these are actually what we call our triangular numbers. Anyways, so number 4, write the first 8 terms in the sequence that represents this situation. Each term should indicate the total number of pennies in each arrangement. So we're going to say that the sequence, let's start here. So I'm going to get rid of these. All right, we know the first one is 1, second one is 3, third one is 6. So what are we want the first 8. So let's put 5 spaces here. Okay. All right, so we need to think about this. Like, what is the pattern that's going on here? Looks like we're not adding a constant amount, but it's kind of similar to the last one where we were taking away an amount based on our previous sequence here. So let's put this. From here to here, we're adding 2. From here to here, we're adding, I should put plus. We're adding 3. So what do we think we're going to add for this next one? And it looks like, right, we just said that the row that's added, it's 1 more penny than the last one. So 1 more. So here we're going to have, since our base right now is 3, it's now going to be 4. It's in between. the pennies that are already in that previous base, and then we have kind of 2 on the far left and far right. So we're adding now 4. So that would look like, I'm just going to draw this real small. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10. Okay. So actually, we'll put that here. This is, we added 2. We added 3. We added 4. What do we think we're going to add for these other ones? All right. So at this point in the video, I'd like for you to pause it, try to figure it out. You don't have to, because it's going to be really hard to draw like all of these different pennies here. So now we're going to move on to just the numerical basis. But try to figure this out. Unpause it when you think you figured it out. But I'm going to go ahead and put it here. Next one, we're going to add 5. So this is 15. We're going to add 6. That is 21. Whoops. Add 7. 21 plus 7 is 28. So it'd be kind of hard to draw 28 pennies. And they're not hard, but it would take some time. So that's why, right, we're just deciding or deciphering this pattern. And now we're going to add 8. So 28 plus 8. Right, like when I do 28 plus 8, I might do, like to do this mentally, I might do like 28 plus, and I'll separate 28, or sorry, 8 into 2 and 6. Because I know 28 plus 2 is 30, and 30 plus 6 is easier to deal with. It's 36. All right. Now, it did say each term should indicate total amount of pennies, but it does say explain your reasoning. So what do we do here? Right. The number of pennies increases, right? It's not decreasing. Increases by, and I should put 2, 3, 4, 5, 6, 7, 8, but I'm just going to draw an arrow here and then circle this. All right, by that. And then every increase, let's put INC, every increase is by 1 more penny than the previous base. Okay, good. And then number 5, explain why the pattern does not increase by the same amount each time. So if it did increase by the same amount each time, I want you to think about what that might look like. This you don't have to draw, but let's say we went to like 1, and I don't know. If I were to increase this again, it would just look like that. And then the second one, or third one would look like this. And the fourth one will look like that. So that's a different pattern of arrangement for pennies here. That doesn't form like this triangular pyramid looking figure. It's just like rows pretty much. So every time Lenny adds a new row onto the base, we'll say the triangle gets wider and takes one more penny. Okay. All right, we're done with that situation. But this, I think, a fairly simple one where we're just adding here. But let's move on to the next one. So really just have, well, we have a couple more contexts. We have 3 more. Let's move on to page 379. Oh, we might make one of these a you do, but let's at least do this one together. Okay. So it says arranging classroom tables. So we're not looking at like classroom desks, but we have tables that seat more than probably 3 students, maybe 4 or 5 students. It says some schools purchase classroom tables that have trapezoid shaped tops rather than rectangular tops. So like we typically see, right, classroom tables like this, but sometimes you might see something like a trapezoid. A trapezoid, for those that, just a refresher, you have 2 lines that are parallel, and then you have opposite sides that are not parallel. So these 2 sides here, that's a trapezoid. The tables fit together nicely to arrange the classroom in a variety of ways. The first diagram shows the number of students that can fit around a table, right? So as you can see here, we can fit 2 students along this long side, 1 student here, another student here, another student here, so a total of 5. And the second diagram shows how you can join the tables on the sides to make one longer table. So if you had like a smaller class and we have a lot of students, right? How can we arrange it to accommodate maybe all these students here? So actually, before we get to that, let's read number 6. Write the first five terms in the sequence that represents the situation. Each term should indicate the total number of students that can sit around 1, 2, 3, 4, 5 tables, and assume that the school joins the tables at the sides as shown. So I guess we have to have one big group, I guess. All right, so let's start with the first one. So the sequence, we'll just say sequence, I'll abbreviate here, let's put colon. The first one, for one table, it's 5 students. Okay, so let's go and account for, I'm just write it in here. There's gonna be 1 student here, 2 students here, or sorry, this is not 2 students, second student. And then along this long side, if you look right here, this was 1, 2, 3 spaces, but it only sat 2 students. So we'll put 3, 4, 5, 6, and then here's gonna be another 2 students for 7 and 8. Okay. And then from here, like maybe you can figure out what the other numbers are, but if we're not sure, then that's where we're gonna draw it. So let's go ahead and draw the third table and see if we can notice a pattern. Okay, so let's draw the first one here, like this. Second and third. All right, you're welcome to pause the video to try to see if you can figure it out. But I'm gonna count here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So it looks like for 3 tables that are all joined, 11 students. So I think at this step, right, the purpose of math is well, one purpose of math I think is to identify patterns, right? Identify patterns to create systems that make everyday calculations or things a lot simpler. So instead of just drawing 4 tables and 5 tables, let's see, can we notice something that's happening here? We have 5, 8, 11. If you think you can figure it out, then write it in. But I'm gonna put here, this will seat 14 students and 17 students. So explain our reasoning here. So as the number of tables increases by 1, what happens with the number of students? We'll say the number of students increases by 3. Right, so each table seats 5 students, but if you just join these tables, right, you're only increasing by 5 students. So you're kind of losing some space, right? You're losing the space of like this joined space right here and here. So that's kind of wasted space there a little bit. But unless you want to form kind of this long table, then I guess it's necessary. But we're going to skip number 7. We're going to do one more and leave the last one as a you-do here. So let's work on building stairs. So here we have this like 3-dimensional figure. Or we got cubes essentially. So it says building stairs. Dawson stacks cubes and configurations that look like stairs. For each configuration, each new configuration has one additional step. Okay, so number 8, it says write the first 5 terms in the sequence that represents a situation. Each term should indicate the number of faces the cubes and the configuration show. Bottom faces are not shown. So what I mean by this, bottom faces not shown, is we don't really see like this like bottom one that's right here. Okay, but let's go ahead and draw the next one. I wonder if I can fit it. Let's put this, I'll put it somewhere right here. Actually, I'm gonna put it over here. We'll go like this. I actually might have went too high, but I'll draw this like pretend point right here. All right, we're going to keep going. This is the second layer here. Okay. This is kind of hard to draw. Okay, I actually made a mistake right there. So that's the second. Let me erase this. Let's go for a third. I think this is it. Let's see. All right, so that's good. So that took a little bit of time. But we have, right, this 1 step, 2 step, and this is the 3rd step. So, so let's go to show here. 1, 2, 3. Okay. All right. So for this, we have to write our sequence. And for this, be careful with this because it's not necessarily a cube shown. It says each term should indicate the number of faces that the cube in the configuration show. The bottom faces are not shown. When we think of a 3-dimensional figure, the face of the figure, this is a face. Okay, it's just a side of a cube. So for this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, so for this first one, it's going to be 5. So this one is 5. The reason it's 5 is because in a cube it has 6 sides, but that bottom side is like resting on the ground, so you can't see that. Okay, so that's a little bit odd thing of looking at something that's in 3 dimensions on a paper that's 2 dimensions. It's hard to notice. But let's go to the next one. So we would have for this one, we would have this side, 2nd, 3rd. We'd have the opposite side for 4th. This top side would be 5th, 6, 7, I think 8 on that side, 9 on this side, 10 on the opposite side, and then we'd have 11 and then 12 on the opposite side of this. So although I'm making these markings, you don't really have to make those markings, but I want you to try to imagine that. This would be 12. Okay. Now this gets more complex as we add figures. So I'm actually just going to give you the third one here because it is somewhat harder to notice. The third one is 21. I wonder if I can find it here. So on the 6 sides, this is 1, 2, 3. There's 4 on the opposite side. And what I mean by that, it's like this side right here. On like the far side that we can't see. So that's 4. Let's go 5, 6, 7, 8, 9, 10, 11, 12, 13. And then we have opposite sides here. So right now we have 13. There'd be a 14 on this side, a 15 on this back side, 16 on this side, and then we would have on the opposite side, so it'd be right the equivalent of this one, which is 17, 18, 19, 20, 21, and the opposite of that side, which is 20, or sorry, it's just 21. We could keep going, but right, what is a pattern that we notice? And if we're not sure, maybe think about like what can you add or what can you multiply? It looks like we are increasing. So let's see what we notice right now. Yeah, we'll think of add. How much are we increasing in this sense? We're adding 7. This one we're adding 9. And what do you think we might add to this one if we continue this pattern? We'll add 11. So this will be 32 for a figure with 4 steps. We're adding 13, so 32 plus 13 is 45. All right, so this one, definitely tougher, but I think it's good to practice, easier sequences and some tougher sequences there. Okay, all right, and then 9 we'll forego, but I'll have you try page 381 as a you-do. So we have 2 different contexts here. One with babysitting, one with recycling, and then let me know if you'd like for me to check those answers and verify them, but we're going to end it there.